Hello everyone. We're going to be looking at inverse functions. The word inverse simply means opposite or reverse. So what we're looking at is two functions because we've got to be able to compare something to say they're opposite or it's the reverse of something. And we're going to look at two functions and show how they are inverse functions of one another. I have graphed one function and it is graphed in orange over on your left. I have graphed a second function and it is graphed in blue and it is on the right. And the thing that I want you to notice with this deals with domain and range. Domain deals with what axis? X-axis. Therefore the x-coordinate. Range deals with y-axis. So we're looking at x values and y values. And if you'll notice, I have graphed or I have plotted some points on the equation y equals 2x plus 2 on its graph. And I have labeled my x values and my y values, and then I have joined them together, writing the coordinate for each one. I have chosen to write the domain in blue and the range in red for my first equation. For the second equation, I'm going to slide this up. I have also plotted points on my graph. And what I've done is I've only listed out these coordinates. But what I have written for this one is that the domain for this one is in red and the range for this one is in blue. And the reason that I did that, if you will notice, -3, -4, they flipped. -4, -3. -2, -2, well, -2, -2. But then at this point I have -1, 0, and they have flipped 0, -1, all the way through to 3, 8, 8, 3. If you will look, my x values became my y values, my domain became my range, my y values became my x values, my range became my domain. They are opposite or reversed of each other. What was once domain, after I take the inverse, becomes range. What was range, once I take the inverse, becomes domain. Okay, so it is important to be able to view this graphically and visualize the changing of the domain to the range and the range to the domain. Whenever you learn, there's three ways: auditory, visual, and kinesthetic, hands-on. All right. So it's important to be able to listen, not just to me, but to others and to yourself. Read aloud. But it's also important to be able to see. Then it is important to be able to do hands-on and work those examples. So this is our auditory and our visual part, more so visual, being able to see, okay, here is a graph, here are my coordinates, here is a graph, here are the coordinates, and they are inverse relationship. Again, inverse means opposite or reversed. I have reversed the domain and range in this one, flipped them to where domain became range and range became domain. And that illustrates a relationship that these two equations are inverse equations. Let's look at that data another way because it does matter how you see it. So this was equation 1, y equals 2x plus 2. This is equation 2, y equals 1/2 x minus 1. And I have written out the coordinates that we identified to where you can see, okay, x-axis domain, it's in blue up here. The range is in red. But down here I have flipped that. the domain is in red, to show you that the values flipped, they're reversed. And you can do that for each one of these coordinates. So the domain of y equals 2x plus 2 is the range of y equals 1/2 x minus 1. And we can say just the opposite. The range of y equals 2x plus 2 is the domain of y equals 1/2 x minus 1, because there is an inverse relationship. Interchanging the first and second coordinates, meaning x and y, of each ordered pair in this kind of relationship produces an inverse relationship. If a relation is defined by an equation, so what you can do is just interchange the variables in that equation. I can take x and put it in place of y and y in place of x. And importantly, the inverse function is written as f, and you can say to a -1 of x, and that means f inverse. You're not actually taking it to a power. It just illustrates this is an inverse function of some other function. So let's look at that. If I have a function, how do I find its inverse function? So starting off with equation 1, y equals 2x plus 2, how I find the inverse function of it is I replace the f of x with y. So I have originally f of x equals 2x plus 2 is how most likely your problem is going to be given. I replace that with y. Y equals 2x plus 2. Then I interchange the variables. I'm reversing it. So I have x equals 2y plus 2. Now I solve for y. Down here, this is important. If you're still not seeing this, this is why I make sure I say it. I can either multiply by 1/2 because I need to get y by itself, or it's the same as dividing by 2. So this is my equation, y equals 1/2 x minus 1. And I can write it like this. The inverse of x equals 1/2 x minus 1. And then if I wanted to graph it, I could just simply replace it with y. This is an equation within itself, but these two together have an inverse relationship. So here are your steps to find the inverse function of another function. What I would like for you to do is pause the video and see if you can solve 1 and 2. Number 1, first thing I'm going to do is I'm going to replace f of x with y. So y equals 2x minus 1. Then I'm going to interchange my variables. X equals 2y minus 1. Now I solve for y. X plus 1 divided by 2 equals y. And there's my equation. Y equals x plus 1 divided by 2. Or I can write it like this. I can say, how about this, 1/2 x plus 1/2. Either way. And then we'll write it using our inverse equation formula. Hopefully we got the same answer on that one. Okay, now if you messed that one up and you think, okay, I messed up the second one, go ahead and pause it again and work it. Okay, replace f of x with y. Y equals 4 over x plus 7. And then I interchange x and y. Now, on this one, what I'm going to do is I'm going to multiply both sides by y plus 7. So I say y plus 7, erase that. And y plus 7. I need to get it into the numerator. That cancels there, so I have y plus 7 times x equals 4. Divide both sides by x. I have y plus 7 equals 4 over x. Y equals 4 over x minus 7. Write it using inverse notation. And there we go. Whoops. The other thing I want to show you, and we'll get to that, but scaffold the learning, is this. These are the two equations that we started off with. What I wanted to show you, whenever you have an inverse relationship between the two equations, there will be symmetry about the y equals x line. So if I draw that line, there will be symmetry about that, and we'll cover that in more detail. But that is an introduction to inverse functions. Remember, it's the reverse, it's the opposite. Domain becomes range, range becomes domain, and follow these steps to go from one equation to its inverse equation. Watch the publisher's videos, critically think and structure your homework, and good luck with your homework.